The work I'm going to present is part of the question answering research conducted at RMIT in the last couple of years. Let us start with our problem setting, which is very simple. We assume a question answering scenario where an asker comes up with a question and an answerer provides an answer to that question. In our work, the asker is always a human and the answer can be a human or a system. The focus of our research is on understanding the notion of answer usefulness perceived by the askers in such a setting. More specifically, we investigate 4 different research questions. The first research question, which is the main one, is about understanding what renders an answer useful for the person who asked that question. Basically here, we are trying to quantify the constituents of a useful answer. The second question is about understanding whether any asker or answer attribute plays a role in the perceived level of answer usefulness. In the third question, we compare human and system answers. And finally, in the fourth question, we try to quantify the success of some commonly used answer quality measures in capturing perceived answer utility. The methodology we followed involves 3 steps. First, we create a taxonomy including 12 aspects to capture the notion of usefulness. Second, we carry out a 3-step editorial study to create a dataset with real-life questions, answers, and some labels associated with the questions and answers, as well as the askers and answerers. Finally, we measure the correlation between our aspects and the perceived usefulness of answers in different parameter settings. So, I'm going to talk about these steps now. The taxonomy we use contains 12 aspects, which are expected to have some correlation with answer utility. These are relevance, correctness, completeness, comprehensiveness, brevity, coherency, serendipity, originality, readability, referencing, factuality, and fairness. We further group these aspects in 4 headings: accuracy, detail, quality, and objectivity. You may refer to the paper for a description of the aspects and the procedure we follow to create the taxonomy. The editorial study was conducted by 12 participants, and it started with a pre-study questionnaire where the participants provided some background information. Overall, we observe a diverse population of participants. There is some bias towards female participants, but we don't expect this to affect our results too much. Most participants are native speakers of English and have different educational backgrounds and expertise. During the study, each participant performed 3 consecutive tasks, which we will talk about in more detail. These are question generation and labeling, answer generation and labeling, and aspect labeling. The first task was to generate some questions. The participants were asked to generate 4 questions in 6 different question intent categories. The intent categories are selected to provide some diversity and to keep the focus mainly on non-factoid questions. The participants had 2 options when generating their questions. They first tried to select a question from their personal search history. If no suitable question was found for the intent category at hand, they could come up with a question off the top of their heads. This way, we obtained 336 questions. In this task, the participants also provided us with some additional information, like the importance of the question for them and the estimated difficulty of the question before and after searching for an answer. In the second task, the questions generated by an asker were provided to another participant, who provided an answer for each of those questions. The answerers could consult any information source they want when creating their answers. The answerers, together with their answers, provided some additional information, such as their interest and knowledge about the question, as well as a usefulness score they estimated for their answer. They also indicated the main information source they used when answering a question. They could answer the question themselves or get the answer from another person, an offline resource like a book, a personal assistant, a mobile or desktop application, a search engine result page, a community question answering site, a news site, any other website excluding CQA and news sites, or any other source not listed here. This table shows the distribution of answer sources indicated by the answerers. The great majority of the answers are obtained from 3 main sources: search engine result pages, the answerers themselves, or a website excluding CQA and news websites. Interestingly, no participant obtained their answers from a personal assistant, despite their increasing use in homes and mobile phones. Also, no participant selected the other resource option, indicating that the options we provided in the study had good coverage. Concurrent to the answer generation task, we generated some system answers obtained from Google Web Search. More specifically, when available, we scraped the content of the featured snippet module, the knowledge base module, and the top results snippet from Google's search engine result pages, as shown in the figure. We compared these answers with human answers when dealing with the third research question. The final task in the study was aspect labeling. Here, the generated answers were passed to the askers of respective questions. The askers then assessed the usefulness of the returned answers. The askers also provided labels for each aspect in the taxonomy. For example, they indicated whether the answer was relevant, comprehensive, or original on a 5-point Likert scale. After all tasks were completed, the participants filled out a post-study questionnaire to let the study coordinators know about their overall experience with the study, whether they found the study challenging, and whether the compensation amount was fair. Of the 12 participants, 10 were satisfied with the study and 2 were neutral. 3 participants found the study easy, while 7 found it medium difficulty, and 2 found it difficult. Finally, the great majority of the participants found the compensation amount fair, while 2 participants felt that the amount should have been less. At the end of the study, each participant was compensated with a gift voucher valued at $500. After obtaining our dataset, we performed some correlation analysis between the aspect labels and the answer utility. Here, we use Spearman's rank correlation since the data is ordinal. The reported values indicate statistical significance for a standard test of the null hypothesis that the correlation is 0. We apply Bonferroni correction to the p-values to account for multiple hypothesis tests. When referring to the strength of the correlations, we use the scale and terminology of Pryan and Hurling. So, we talk about negligible, weak, moderate, strong, and very strong correlations. In the rest of the presentation, I will go over our results for each research question, starting with our Q1. In this table, the first column shows the aspects in our taxonomy, and the last column shows the correlation between the aspects and the perceived answer utility. We see that completeness, relevance, comprehensiveness, and correctness of the answers have strong correlation with answer utility. Here we note that, except for the last 2 aspects in the table, all results are statistically significant. Also, we see that the correlation between the individual aspects is not very strong. This means that the aspects we selected are not duplicates of each other. In this slide, we show the correlation between the perceived usefulness of answers and certain attributes of askers and answerers. The attributes are shown in the first column of the table. These are the importance of the question to the asker, pre-search and post-search question difficulty predicted by the asker, the interest and knowledge of the answerer about the question, and finally, the usefulness of the answers estimated by the answerers. According to the last column, all of these attributes have negligible correlation with the perceived answer utility. We also note that none of the correlation values is statistically significant, so we will not spend much time with this table. In the third research question, we compare human and system answers. The first column shows the question type where F and NF stand for factoid and non-factoid questions, respectively. The second column shows the source module for the search snippets we are comparing with human answers. These are FSM, KBM, and SRM, which stand for the featured snippet module, knowledge base module, and search result module. The bottom part of the last column of the table shows the average utility difference between human answers and system answers for non-factoid questions. According to this, the featured snippets and knowledge-based snippets are perceived as more useful than even human answers, while the regular search result snippets are much less useful. The results are statistically significant for featured snippets and search result snippets. Our final result is about the performance of various answer quality measures in capturing the aspects in our taxonomy and the perceived answer utility. The first column in the table shows the measures we considered. These are three versions of the Rouge measure, BLEU, METEOR, and BERTScore. According to the last column of the table, the recently proposed BERTScore measure slightly outperforms more traditional measures. None of the measures have strong correlation with our aspects. We see that all measures have moderate correlation with the correctness aspect, and in general they have higher correlation with aspects that are about accuracy and detail, and lower correlation with aspects that are about quality and objectivity, which are more difficult to capture. Here is a summary of our findings. First, for non-factoid questions, the usefulness of answers is strongly correlated with four aspects: completeness, relevance, comprehensiveness, and correctness. As a side note, for factoid questions, the important aspects are similar, except that comprehensiveness is replaced with factuality. Second, there is negligible correlation between the perceived usefulness of answers and attributes of askers and answerers. And we should also state that most correlations were not statistically significant. Third, the system answers retrieved from Google's featured snippet and knowledge base modules were perceived as more useful than human answers. Fourth, BERTScore slightly outperforms the three commonly used answer quality measures, Rouge, BLEU, and METEOR, in capturing usefulness of answers. Here are some potential implications of our work in practice. First, aspects such as completeness and comprehensiveness are almost as equally important as relevance and correctness, which are the main optimization metrics for the question answering systems we have today. So, question answering systems should consider these aspects as well. Second, deciding the optimal verbosity of answers displayed to users may have practical importance in commercial web search engines, given that multiple result modules compete for the limited search space in such search engines. So, this may be an interesting problem to tackle. Third, there is a major difference in the perceived usefulness of the regular search result snippets and more advanced snippets, such as featured snippets and knowledge-based snippets, which may be more costly to generate. This raises interesting questions about the trade-off between the quality and cost of snippet extraction algorithms used in practical search systems. You may refer to the paper for further results and findings. Thanks for watching.